social problems arising. Supposing we can design human beings, how ought we to design them? Is intelligence that important? Do we want to have everybody double domes? Do you want everyone to have blue eyes or everyone brown eyes? So that we not only have to expect change, but we have to be able to control it a little bit. And in order to control it sensibly, we have to know in advance what's likely to happen. And the purpose of this program is to advance ideas and suggestions as to what is liable to happen, what is on the frontiers of science now, and how possibly we ought to react to it. When I began to write science fiction way back in the 1930s, or the Middle Ages as I like to think of it, that was a time when space travel was absolutely science fiction. Even a trip to the moon was science fiction. One of my first stories was about someone getting into a rocket ship and going around the moon and coming back. And boy, was that a stroke of imagination on my part. And now, long since, we've reached the moon in much more complicated fashion than I dreamed of in my science fiction. We've done much more. We live in a space-centered society practically now. We can't do without our satellites, communication satellites, our navigation satellites, our spy satellites. And the odd thing is that if we were only to go back 40 years and try to talk about it, everyone would sneer. The next logical aim is to reach Mars, and that requires a trip of perhaps a year and a half or more, so that in order to do that, we are not likely to be able to start from Earth itself. We are going to have to build space stations, which are in the works. We're planning them. On the space stations, people are going to work for indefinite periods of time, in shifts undoubtedly. And that will be the launching pad, the long trips, the ones to Mars. And Mars is a different thing from the moon altogether. It's much more like Earth. It has an atmosphere, has polar ice caps, it's got the signs of ancient rivers and so on. We may discover a great deal about Earth by going to Mars. That's the point we must never forget. We're not just going out there to go out there. We're going out there to learn more about ourselves and our own world and our own lives. And we mustn't think of space stations as only a place from which to launch trips far out. We can also use it as a base for people to work in space over extended periods of time to build all the structures that we're going to need in space. Solar power stations to supply the Earth with energy, maybe even places where people can live, tens of thousands of them, in space settlements orbiting about the Earth. We can have really an extension of the human range by way of the space stations. One of the big problems of space is the energy it costs us. The rockets we use now are extremely primitive, use incredible amounts of energy in order to do comparatively little. And we have to wonder, is there any way we can make long trips without concomitant increases in the amount of energy we use? And one of the possibilities is to go back to sailing ships. You know, in the old days before we ran ships on steam, on burning oil, we used the wind. And it blew into the sails. Silently and without energy expenditure, drove the ships over the ocean. And now we have another kind of wind, a wind that comes from the sun, a series of particles always driving outward. And if we had sails large enough, this solar wind could push us here and there. And there are ways of doing such a thing which would save greatly on energy, but which would require other great advances, because you would need sails that were many square miles in area and yet were comparatively light. But we have the vision. of the clipper ships of the future sailing through the solar system. And we have to realize just exactly how large the universe is. The moon is only 250,000 miles away. Jupiter is 500 million miles away. Pluto is 2 to 4 billion miles away, depending on where it is in its orbit. And the nearest star, Alpha Centauri, is 7,000 times as far away as Pluto is. Light, which travels faster than anything else in the world, 186,282 miles each second, takes 4.3 years to reach Alpha Centauri. And Alpha Centauri is the nearest star. Our Milky Way galaxy is 100,000 light years from end to end. The Andromeda galaxy, the nearest large galaxy to us, is 2.3 million light years away. The nearest quasar is 1 billion light years away, and we have been studying objects that are up to 16 or 17 billion light years away. It's very unlikely we'll ever be able to cover such vast distances. It may even be difficult ever to reach just the nearest star. But if we can't go there, they, in a sense, can come to us because we receive light from all parts of the universe, even the farthest. And the difficulty is, of course, that in the first place, some of the light is dim indeed when it comes long distances. And in the second place, it must penetrate our atmosphere, which absorbs and distorts some of the light and other radiation that ought to reach us. For that purpose, scientists have long dreamed of a large telescope in space which can observe the universe from outside our atmosphere and see things much more clearly and sharply. One of the things we're looking for through the Hubble Space Telescope is just exactly what the universe looks like very far away, billions of light years away, because it takes light billions of years to reach us from those distant places, so that we're seeing light and objects as they were not long after the universe came into being. We may be seeing objects as they were only 1 billion years or so after the universe was first formed. Now, we don't know much about the early stages of the universe. If we can find out more about it through the Hubble Space Telescope, we'll know more about how the universe developed to its present state from its origins and where it might be going in the future. In short, it's going to be telling us a little bit about where we came from and where we're heading. Furthermore, there are many objects in space that the Hubble Space Telescope will be able to see more clearly inside of, so to speak. For instance, there are globular clusters that contain 100,000 stars in a almost tightly packed ball. To us, from here on the surface of the Earth, it's just a blur of light. But through the Hubble Space Telescope, we may be able to see into the interior of the cluster, or into the interior of some of the centers of the nearer galaxies, and perhaps be able to see if, as we think, there are black holes there. We'll learn more about black holes, and again, who knows what this will tell us about the universe as a whole. We can make sharper measurements of the positions of stars, be able to tell more accurately just exactly how they're moving, how fast, in what direction, and from that, be able to understand what the circulation of the stars is in our Milky Way, and therefore how our sun is traveling through it, and be able to find out just exactly how the galaxies are moving, how the universe is expanding. It may give us discoveries that we can't imagine now, simply because we've never seen anything clearly enough to make those discoveries. It's impossible to predict what they will be. That's one of the great excitements of science, that always there is the unexpected. Always there is something that no one thought of that completely revolutionizes our thoughts in this direction or that. It's a kind of excitement that keeps scientists going, I assure you. And if the population generally can be made to share in it, how much pleasure they will have.